Hey everybody, today I want to show you a way to find differences between two buffers and restoring back to an old version. And this is useful to implement things like undo and redo. This is in fact the method that I'm using for a game that I'm working on from time to time. Hey guys, this is just a quick demo to show you how the undo works on my game using the same method that I'm showing you in the video. You can see that here I'm in the map editor where I can place some grass, right? And then I can hit Ctrl C to restore back those changes. I can also move units, Ctrl C. You can see how everything gets reverted. And this is again just using the same method that I showed you in the video. Hope you enjoyed. And so this is a very simple how can I say this? This is actually quite simple, but I struggle to explain this. So hopefully this video will come out fairly good. So maybe I can show you a visual representation of what's gonna happen. In here we can see that we got two buffers. We can say that this is the version 1 of the buffer, whoops, and this is the second version, or we can say this is the old version and this is the new version. And we can see that in the buffer we got a difference, right? In the fourth box we have made a change. And so what we want to do, instead of having to store an entire copy for each change, we just want to save in the index at which the difference happened plus the actual value, right? Which is basically, we just want to save this box. So let's see how we can do this in the code. So in here we got the two buffers, right? Then again, these two. And we're gonna call this function, right? We're gonna say, well, find me the differences between these two versions, and the size of these two buffers is 256, right? This is just a number that I made up. And we're gonna see in a few minutes how we can change this, and it will even it will just work with whatever we pass it, right? So once we find the differences, we can print how many we found, right? How many boxes we found. We print the new version, and then we try to restore back to the old version based on those differences that we found, and we're gonna print that out, right? And we can see how this we can see the output. Let's see. Right, we can see that we found two differences. This is the new version, and then we restore this version back to the original one, and you can see the result after doing that, right? So you can see how the state mutated from this to this, but then we went back from here to here, right? Let's see how we implemented this function. First of all, we mentioned that we need a way to store the start, the index of where the difference begins in the buffer, and the actual value, right? The box that we saw in the picture, right? Then we got some global variables, which is these are going to be used to store the differences, right? And how many we found. Now we take two buffers, right? We're gonna go through all the bytes inside of these two buffers, and we're gonna try to find differences. If we don't find anything, we just continue with the next byte, right? But as soon as we found a difference, we store the index, right? In the picture again, it would be here. And then we proceed to store the actual value, right? The difference, which is this, right? And with that, we just increment how many differences we have found, and we advance as many bytes as we needed to copy, right? Which is basically the difference in itself, right? Now, in here, I used a U64 to store the difference, but you could use whatever, right? You could say, well, I just want 4 bytes, or maybe you want to store larger chunks, right? Maybe you want to store something like this. It doesn't matter. In my use case, I found that just using a U64 is plenty. So that's what I'm doing. This could be a bit confusing, right? How can you store the difference in a number? Well, the thing is that you could think about this as a number, or you could think of a buffer with 8 bytes, right? The only thing that changed, the difference is how we interpret the data, right? Alright, so moving on, you can see that in here, this is a very small check to make sure that we don't copy past the size of the buffer, right? Let's say that we are here. Let's make sure that we copy up to here and not here, right? And then when restoring, it's just a matter of gathering the differences, going through all the differences, and then copying the patches of those differences back into the buffer, right? So it's basically saying, well, if we happen to store this difference, right, we would say, well, let's go to this difference. The difference begins right here, and this is the data, right? So basically, we're just copying the data from this difference back to this new buffer. And that's how the whole system works. It's very simple. It's basically just copying patches of memories from one buffer back to the new version, right? Hopefully that makes sense, right? And then we can again run this, and you can see how we can restore this, right? Now let's say that we don't have just text, right? What if we happen to have like, I don't know, the state of some unit, right? Let's pretend that, or even better, let's say we got a player, right? We got a position X, position Y, and some random score. Oops, score, right? And so you have to think that this is just another buffer. Instead of being a string, this buffer contains 3 integers, right? So we can do player A and player B, right? And then we can say player A has these coordinates, right? And after doing something, let's say that B has the same state, and now we update this score to be 32, right? And so this will have the same state here, but now we update the star of the new version, right? And we can say, well, I suppose we can leave those names just fine. So how do we use the new how do we use this function with these two buffers? Well, it's a matter of just passing the address, right? Just like that. And then we have to say struct, right? We have to specify how long or how big is this buffer, right? So now instead of printing this, we're gonna print the score because that's the only thing that changed, right? We're gonna say player B score, and then we're gonna restore back to the old version, right? So this is pretty much the same. Just wanna copy that up, and then we're gonna copy this as well. We're gonna say player B score after restoring back the version. And we'll see if this works. And you can see that it does, right? We went from 32 back to the old version, right? And we didn't have to implement something like a command pattern. For those of you familiar with object-oriented patterns, right? It's just a matter of understanding how the memory works. So yeah, guys, hopefully this is somehow useful. Just wanted to put out a quick video, and to be honest, I don't know how many times I try to record this video. I think this is like the 5th time. I don't know. Hopefully the end result is good enough. Alright guys, take good care.